Galaxies in Chaos. James Webb reveals the wild origins of the universe. A universe born in chaos. The story of galaxies, the sprawling islands of stars that light up our night sky, begins not with beauty, but with disorder. Today, when we look at spiral galaxies like the Milky Way or Andromeda, we see elegant arms winding gracefully around a central bulge. These shapes suggest order, symmetry, and harmony. But if we turn our gaze back in time, billions of years into the past, the picture becomes very different. Thanks to the James Webb Space Telescope, JWST, humanity now has a window into an era of cosmic history that was, until recently, hidden in darkness. JWST's infrared eyes can pierce through dust and stretch across time itself, reaching back to just a few 100 million years after the Big Bang. What it reveals is not the serene order of galaxies we know today, but violent turbulence, a universe still in its infancy, filled with chaotic, messy, and irregular structures. Astronomers observing more than 250 young galaxies discovered that their shapes bore little resemblance to the neat spirals of the modern universe. Instead, they were twisted knots of gas, turbulent clouds of star formation, and gravitational wreckage from constant collisions. Far from being the grand architectures of stars we admire in textbooks, these galaxies were like construction sites, loud, unstable, and full of debris. This is not just an aesthetic revelation. It tells us something profound. The universe did not grow in a straight line from simplicity to complexity. It grew through violence, through conflict, through chaos. And in that chaos, the seeds of everything we know today, stars, planets, and life itself, were planted. The age of reionization, when the lights came on. To understand why the early galaxies looked so strange, we need to step even further back into what astronomers call the epoch of reionization. This was the era, roughly 400 to 800 million years after the Big Bang, when the first galaxies and stars ignited enough light to change the universe forever. Before this time, the cosmos was a foggy, opaque sea of neutral hydrogen. Photons, the particles of light, could not travel far without being absorbed by atoms. The universe was dark and unrecognizable, even though matter had already started to clump under gravity. When the first stars were born, their intense radiation began to ionize the surrounding hydrogen, stripping electrons from atoms and allowing light to move freely through space. It was like a cosmic sunrise. Suddenly, regions of the universe that were once shrouded in darkness became transparent. This was the true dawn of structure, the moment when the young galaxies first revealed themselves. But those galaxies were nothing like the mature spirals or ellipticals we catalog today. They were small, turbulent, and fragile. They were still assembling their mass, still accreting gas, still merging with neighbors. And because the universe itself was denser at that time, collisions were inevitable and frequent. The age of reionization was not just a time of illumination. It was also a time of chaos, a laboratory where the laws of physics played out on scales beyond imagination. Every burst of star formation, every collision between galaxies, every supernova explosion fed into the turbulent picture that JWST now captures with such unprecedented clarity. The first galaxies, clumps of gas and fire. When astronomers first pointed JWST at deep fields, those tiny patches of sky chosen to reveal the faintest galaxies, they expected to see some irregularity, but not to this extent. Instead of small but recognizable spirals, what they found were amorphous blobs of light, riddled with knots and streaks. These were galaxies in the making, barely holding themselves together. Each of these galaxies contained vast amounts of gas, collapsing under gravity to form new stars. But the process was anything but smooth. The gas was stirred by turbulence, shredded by supernova, and disrupted by constant inflows and outflows. In many cases, these galaxies were not single structures at all, but multiple fragments bound loosely together, fated to merge into larger systems. The young galaxies were also incredibly bright, not because they were stable, but because they were sites of furious star formation. Stars were being born at rates far higher than in the Milky Way today. Some of these early galaxies produced hundreds or even thousands of new stars every year, a pace that makes our galaxy's modest star formation rate of 1 or 2 stars per year seem almost lazy. Yet these bursts of creation came at a cost. The energy from newborn stars and exploding supernova often tore apart the very clouds of gas that created them. Imagine a construction crew building a skyscraper, only to have half the structure collapse every few hours, forcing them to rebuild again and again. That was the reality of these early galaxies. Progress through destruction, growth through instability. Even gravity itself seemed barely enough to keep things together. In a universe only a few 100 million years old, galaxies were still small compared to the giants we know today. Their masses were limited, their dark matter halos still growing, their ability to resist disruption still fragile. Many of them may not have survived at all, vanishing into mergers and collapses, leaving no descendants for us to observe. What JWST shows us is not a finished universe, but a universe under construction. Every messy, irregular, chaotic galaxy we see in its images is a reminder that the order we admire today is built on a foundation of turbulence. The Milky Way itself was once such a chaotic mess, colliding, consuming, and growing until it became the majestic spiral we call home. Why they were not spirals? When people imagine galaxies, they often picture the iconic spirals, grand arms curling outward in symmetric patterns, glowing with billions of stars. The Milky Way, our cosmic home, is one such spiral, a structure so vast and so orderly that it gives an impression of timelessness. But spirals are the end result of a long evolutionary process, not the starting point. Why were the first galaxies not spirals? The answer lies in physics. Spiral arms require stability, rotation, and enough time for stars and gas to settle into ordered orbits. In the early universe, none of those conditions were present. First, the matter that composed galaxies was distributed unevenly. Gravity pulled gas and dark matter together, but the clumps that formed were irregular and asymmetric. Rather than smooth disks, galaxies began as lopsided clouds, with mass distributed in patches rather than in a balanced plane. Second, turbulence dominated. Imagine a stormy sea, waves crashing and colliding from every direction. Early galaxies were like that ocean, but made of gas and stars. Supernova injected energy into the gas, sending shockwaves that distorted the fragile structures. Collisions between galaxies were common, stirring the material even further. Instead of the calm rotation needed to form spirals, there was chaos. Third, the time scale was simply too short. Spirals take billions of years to emerge. Stars need to orbit many times around the galactic center, gradually shaping arms through density waves. But in galaxies only a few 100 million years old, there had not been enough time for these orderly patterns to appear. Subscribe and explore the universe with us. In other words, spirals are a luxury of maturity. The galaxies of the early universe had not earned that luxury yet. They were children, still stumbling, still trying to find their balance. And like children learning to walk, they often fell, merging, collapsing, and reforming. What JWST reveals is that our expectation of seeing miniature spirals in the early universe was misguided. Galaxies did not start neat and become messy. They started messy, and only over billions of years did they become neat. Turbulence and mergers. If there is one word that captures the reality of the early universe, it is turbulence. The galaxies JWST shows us are not static objects. They are arenas of constant motion, where forces tear at one another, where structures build and collapse in cycles of violence and renewal. One of the biggest drivers of this turbulence was mergers. Because the universe was denser in its youth, galaxies were much closer together than they are now. Distances that would seem vast today, millions of light years, were mere cosmic neighborhoods back then. Gravity pulled galaxies together, and collisions were inevitable. When two young galaxies collided, the result was rarely graceful. Unlike stars, which are so small compared to the distances between them that they rarely crash directly, gas clouds were vast and sprawling. When galaxies merged, their gas clouds smashed together, compressing and triggering enormous waves of star formation. For a short time, the galaxy would blaze with new stars, a starburst. But this brilliance was unstable. The same processes that created stars also created chaos. The energy from mergers sent gas streaming in chaotic flows. Some was driven toward the galactic center, feeding nascent black holes that could one day grow into quasars. Other gas was flung outward, creating streams and tails that left galaxies ragged and torn. Instead of smooth disks, the galaxies became twisted, asymmetric, and scarred. At the same time, turbulence inside galaxies was amplified by feedback from stars. Every time a massive star was born, it poured radiation and stellar winds into the surrounding gas, disrupting it. When it died in a supernova, the explosion blasted more chaos into the system. The balance between creation and destruction was delicate and constantly shifting. Astronomers describe this process as violent relaxation, a fitting phrase for a universe in turmoil. Out of this violence, galaxies eventually relaxed into more stable shapes, but not before enduring countless collisions and disruptions. Mergers did more than create turbulence. They also built galaxies up. The Milky Way itself is thought to be the result of dozens, perhaps hundreds, of mergers over billions of years. Each chaotic union added more stars, more gas, and more dark matter to the growing system. Without mergers, galaxies might never have grown large enough to survive. So when we look at the messy galaxies of the early universe, we are not seeing failure. We are seeing growth. Every irregular clump, every jagged feature is evidence of galaxies fighting to become more than they were. From chaos to order, the story of galaxies is not just about chaos. It is also about the emergence of order from that chaos. Over billions of years, the violent collisions and turbulent flows that defined the early universe began to settle. Out of destruction came creation, and out of instability came structure. How did this transformation happen? The key lies in gravity. While turbulence and mergers created short-term disorder, gravity acted as the great organizer. Slowly but relentlessly, it pulled stars and gas into orbits, smoothing out irregularities. Over time, galaxies rotated enough that spiral patterns could emerge. Dark matter also played a crucial role. Although invisible, it provided the scaffolding on which galaxies grew. Dark matter halos extended far beyond the visible regions of galaxies, holding them together during collisions and preventing them from flying apart. Without this hidden skeleton, galaxies might never have survived the chaos of their youth. Dark matter also played a crucial role. Although invisible, it provided the scaffolding on which galaxies grew. Dark matter halos extended far beyond the visible regions of galaxy. Star formation, too, contributed to order. As galaxies formed more stars, their gravitational pull increased, deepening the wells that held gas and dust in place. The energy from young stars was disruptive, but it also enriched the galaxies with heavier elements, seeding future generations of stars and planets. Gradually, the jagged clumps gave way to smoother disks. The violent starbursts slowed, replaced by steadier rates of star formation. Collisions became less frequent as the universe expanded and galaxies drifted farther apart. Out of the storm, calm began to emerge. This transition from chaos to order is one of the most remarkable stories in cosmic history. It reminds us that the universe is not static, but evolving. That beauty can arise from violence, that structure can emerge from disorder. The Milky Way is living proof of this. Once it too was a messy clump of gas and stars, colliding with neighbors, ripped apart by turbulence. Today, it is a majestic spiral, home to hundreds of billions of stars and at least one planet where life has taken root. When we look at JWST's images of chaotic young galaxies, we are looking not at something alien, but at our own past. We are seeing the childhood of the galaxy we live in, and in that childhood, we see the seeds of everything that would follow. What JWST revealed and why it matters. The James Webb Space Telescope was designed to do many things. Study the atmospheres of exoplanets, peer into star-forming regions, analyze the chemistry of distant nebulae. But one of its most ambitious goals was to look deeper into time than any telescope before it. By observing in infrared light, JWST can see galaxies whose light has traveled more than 13 billion years to reach us. Galaxies formed only a few hundred million years after the Big Bang. What it found has reshaped our understanding of cosmic history. Instead of discovering small, well-structured spiral galaxies, Webb revealed clumpy, turbulent, and irregular systems. These galaxies were building blocks, not finished products. They were still forming stars at furious rates, still colliding with neighbors, still sculpted by flows of gas and dark matter. This discovery matters for several reasons. First, it confirms theoretical models. For decades, cosmologists predicted that galaxy formation would be messy. Simulations showed that turbulence, mergers, and feedback would dominate the early universe. Now, for the first time, we have observational proof. Second, it challenges our assumptions about how quickly order can emerge. Some of the galaxies JWST observed were surprisingly massive for their age, suggesting that galaxies can grow faster than previously thought. This raises new questions. How did they accumulate so much material so quickly? What role did dark matter halos play? Third, it connects us to our own story. By seeing galaxies in their chaotic infancy, we are glimpsing what the Milky Way once looked like. We are looking at our galaxy's baby pictures. This is not just abstract science. It is personal. Finally, it reminds us that science is not finished. Every answer leads to new questions. JWST has shown us the mechanisms of the early universe, but we still don't know exactly how order emerged, how supermassive black holes grew so fast, or how the first stars enriched the cosmos with heavy elements. These mysteries remain to be solved. Finally, it reminds us that science is never truly finished. Every discovery answers one question, only to uncover a dozen more. The James Webb Space Telescope has shown us the universe not as a calm, orderly place, but as a living, breathing cosmos, wild, turbulent, and alive with creation. We've seen the first galaxies take shape out of chaos. We've glimpsed the infancy of light itself. And yet, we still don't know everything. How did chaos turn into order? How did black holes grow so quickly? Or how did the first stars fill the void with heavy elements? The same elements that would one day form worlds, oceans, and life? These mysteries remain, but that's the beauty of science. It never truly ends. Each telescope, each question, each spark of curiosity takes us a little further into the unknown, because the story of the universe is not finished. It's still being written by us,